Hello everyone. Hi guys. Please confirm once that am I audible to you and am I visible to you? And mark your attendance please. Hi, good afternoon, Shillong, Tamelong. So guys, what's going on? Have you taken your lunch? Okay. So guys, please tell me what was the topic we were discussing in the previous class. Please show centers please. Okay, hi Itanago. What about you, Senapati? Are you there? So guys, are you ready for the class? Okay, application of Bose atomic model. We have discussed with all the formulas. Okay. So, guys, let's begin with our class. Okay. See, in the previous class, we have discussed about the formulas related which is derived by the Bohr. Okay, that was the application of the Bose atomic model that is covered. Now, we need to deal with the few important terms that you will find in your examinations. Okay. Hi, good afternoon, Sisipo. So guys, let's begin once. See, some important terms. Guys, settle down fast, please. Kindly adjust your curtains. No, if you want to adjust. Done? You need some more time? Okay. So guys, let's begin with some important terms. So guys, first one is your ground state. Ground state. See, the lowest energy state of any atom or ion is known as the ground state. Okay. Lowest energy state of any atom or ion. Okay. Next is your excited state. Okay. So guys, all the other states other than the ground state are known as what? Excited states. Ultimately, we can say that states which are other than the ground state are known as what? Excited state. Okay, except ground state, all the states will be termed as excited state. Okay, the states of an atom or ion don't say ion, simply say atom other than ground state. Okay, good. So guys, this is the definition for the excited state. Now look at this very carefully. See, if we say first excited state, guys, see, we are talking about the hydrogen-like species. Ultimately, we are saying that those species, those atoms or ions which has got the single electrons. Okay, so if we talk about the first excited state, it means that n equal to 1 will be your ground state. Okay, and if we talk about the next state, which is other than the ground state, which will be present at n equal to 2. So for the first excited state, n should be equals to 2. Okay, see, let me explain it little bit. See, guys, look at this. This is n equal to 1. This is your ground state. Okay, so guys, after the ground state, where will you find the first excited state? Obviously, just next orbit of the ground state, which is this one. Okay, and this one n equal to is what? 2. So this is your first excited state. If I talk you about the second excited state, that obviously it should be present at n equal to what? 3. If I talk about third excited state, it means that it will be present here. Okay, at n equal to 1, you will get the ground state, and after that all the states will be what? Excited state. Okay, just you have to do what? That if we talk about the first excited state, then you have to just add 1 in the ground state. Okay, because we are talking about the hydrogen-like species, that's why ground state is what? 1. Okay, if I say second excited state, it means n will be equals to 3. If I say third excited state, then n would be equals to what? 4. If I say fourth excited state, then n would be equals to what? 5, and so on. Now you can copy this. Please copy this. Guys, is it clear to you? Is it clear to you? Okay. Okay, Tanago, Sisipo, Tamelong, and what about other? Okay. Very good. Copy, please. Copied. Okay, cool. So guys, these are the basic definitions. Okay, next is number 3rd, ionization energy. So guys, when we talk about the ionization energy, it is your minimum energy required to remove the electron from ground state to the infinity. Ultimately, we can say that it is the energy required to move the electron from ground state to the infinity. Okay. So ionization means something which we have to convert into ions. That is what? Ionization. Okay. That neutral species when converted into ions is known as what? Ionization. Now, if we talk about its definition, it is your minimum energy required to shift electron from ground state to infinite. Okay. So guys, if we talk about N1, it should be equals to 1, but if we talk about N2, that should be your infinity. Okay. Please copy this. Next is your separation. Next is your separation or binding energy. Guys, in the ionization energy, we shift the electron from ground state to the infinity, whereas in case of separation or binding energy, we actually shift the electron from excited state to the infinity. Okay. This is what? Energy required to shift the electron from any of the excited state to the infinity. Okay. So guys, N1 can be your 2, 3, 4, 5 and so on, whereas N2 would be infinity. Okay. Next is your excitation energy. Ultimately, the energy supplied by you to excite the electron, ultimately to shift the electron from ground state to any other excited state. Okay. See, this time we need not to shift it to the infinity. Okay, because if we shift it to the infinity, it will become the ionization energy. Okay. What we have to do? We have to supply the energy so that the electron will shift from its ground state to the any other excited state. Okay. So this is your energy required to shift the electron from ground state to any other excited state. Okay. Here N1 will be 1, but N2 can be your 2, 3, 4, 5 and so on. It can be anything. Okay. Please copy this. Is there anyone who has got any confusion regarding any definition? They wants me to clear that. Anyone who needs some more clarification on any definition or any part? Yeah, it's charging. Settle down. Okay. Can I move on? Is it clear to everyone? Okay, 1. Okay. What about other students at the Shillong Center? And okay, still there are 3 students who are busy with their own stuffs. Second and third bench, I'm talking to you. Is it clear to you? Any confusion or doubt? Okay. And what about other students, guys? What about you? Sisipo, Temenlong? Any point of confusion or doubt? Can I move on? Okay. So guys, these are the few basic definition, okay, that should be clear to you. Now, see, we have seen that the delta E can be written like this, En2 minus En1. Okay. Guys, look at the screen first. After that, I'll give you time to copy that. Okay. See, we know that energy of the stationary state can be written like this, minus 2.18 into 10 to the power minus 18 z square upon n2 square minus 2.18 into 10 to the power minus 18 z square upon n1 square. I think so it is clear to everyone that I have just putting the value, okay. These formulas is already been discussed with you. Now I am just simplifying it, okay. We can take 2.18 common and 10 to the power minus 18. Inside we will get 1 upon n1 square minus 1 upon n2 square into z square, okay. This is your one of the formulas for delta E. This is in joule per atom. One of the formulas, okay. Please copy this formula first and then we'll move on. Done. Okay. So let's move on. Now, okay. Now, we know that delta E can be written like this, Hc upon lambda. We have already seen this relation, so I am putting this value over there just. So, see, Hc upon lambda would be equals to 2.18 into 10 to the power minus 18, 1 by n1 square minus 1 by n2 square into z square, okay. Now, we know that H is a constant, C is a constant, so I can write it like this: 2.18 into 10 to the power minus 18 upon HC, 1 by n1 square minus 1 by n2 square. Okay. So guys, we can solve this h of 2.18 10 to the power minus 18 upon HC. This will be a constant. Okay. So on solving this, we will get 109677 1 by n1 square minus 1 by n2 square z square. Okay. Further, I can write this formula like this. This is your wave number is equals to 1.09677 into 10 to the power 7 1 by n1 square minus 1 by n2 square meter inverse. Guys, this is your Rydberg constant. Yeah, I'm doing that. Please look at the formula first. Look at the derivation first. I'll give you time to copy that. Okay, don't worry. This is your Rydberg constant, and this formula is known as what? Rydberg's formula. Rydberg's formula. Okay. Now you can copy this. Is it clear to everybody? Is there anyone who wants to ask me anything regarding this one, regarding this derivation? Okay. Copy this, and after that you can just tell me. Over. Okay. Copy this. By the way, guys, what you do on Diwali, on the festival Diwali, how do you celebrate? Okay. You celebrate Christmas? Oh, that's good. Okay. So guys, have you copied that? We'll talk about that. How do you celebrate your Christmas? Okay. Okay. Done? Are you done with that? Okay, so let's move on, guys. Okay, guys, listen to me very carefully. What I'm trying to say. that you need not to copy this, you have to just understand that why do we have derived that formula. Okay, what is the reason behind that? See, that formula was driven by the Rydberg. Anybody knows who was Rydberg? Who was Rydberg? No one? Okay, it's okay. See, let's say suppose electron is present over here. Okay, when it jumps from its lower excited state to higher excited state, let's say suppose in here. Okay, so definitely during this transition it will have certain energy. Okay, and that energy or radiation will have a definite certain wavelength of frequency. Okay, see, during this transition, this is 1, this is 2, during this transition it will have definitely certain energy, or we can say that energy will definitely have some wavelength of frequency. Okay, so that particular frequency of wavelength which is available to us during this transition can be calculated or determined by that formula which is given by the Rydberg. See, this formula helps us to determine the frequency or the wavelength which is being used during the transition from one state to another state. Okay, so we have to remember this formula directly. Okay, and one more important thing, that please do not use this big number. See, this is represented by the RH. Okay, this is the Rydberg constant for hydrogen atom, which is equals to 1.09677 into 10 to the power 7. Okay, see, you can simply use this one, 1.1 in 10 to the power 7, that's it, for the calculation purposes. Okay, need not to write that big value, 1.09677 and so on. So guys, is it clear to you that why do we using this formula? Anybody wants to ask me anything, any confusion? Can I move on? Do you need some more explanation on this one? Anyone? Okay, one is saying no. Hey guys, is everything going on fine? Is everything going on fine? Any problem? Okay. Okay, so guys, this was the Rydberg formula. Okay, cool. So guys, this was the Rydberg formula. Now, let's see. We were talking about the ionization enthalpy. Guys, see, what can we do with that formula? Delta E, we have just discussed that delta E. I am writing the R. R is a constant which is 2.18 10 to the power minus 18. 1 by N1 square minus 1 by N2 square into Z square. Okay. If I talk about the ionization energy, okay, guys, look at the definition of the ionization energy. When we talk about the ionization energy, N1 is 1 and N2 is infinity. See, N1 is 1 and N2 is infinity into Z square. Okay. So on putting down these values, we will get 2.18 into 10 to the power minus 18 into Z square. Are you getting this? That how those formula, I mean those definition are used here. How we can use those definitions over here. Okay. In the similar manner, we can use it for the excitation energy, ionization energy, binding energy, separation energy. Okay, all those definitions that we have discussed over there. Okay, so this is just a example. You can copy this, okay, because you have to deal with these kind of problems. Please copy this first. Now this is the question time. This is a question for you. Calculate energy of Li2 plus ion for second excited state. First of all, you have to derive the formula, that how that formula will be changed. Delta E equals to 2.18 10 to the power minus 18, 1 by n1 square minus 1 by n2 square into z square. Okay. Second excited state. And tell me the answer. You can, guys, you can calculate the answer in electron volts as well. Okay. If it is easy to you, I think so electron volt is easy to deal with. So you can calculate in electron volts as well. Okay. Guys, read the question very carefully. You have to calculate the energy of second excited state. Energy of second excited state. Anyone there who got, anyone who has got the answer? Okay. See, guys, do not copy anything. First of all, clear the question. Okay. Delta E is equals to 13.6. Do not copy this. 1 by n1 square minus 1 by n2 square into z square. How many of you have used this formula? How many of you has used this formula? Because in the beginning I told you to use this formula, and I guess so you have attempted in that manner. Guys, after that statement I told you that read the question very carefully. In the question, see, in the question it is given to you that calculate the energy of the lithium ion for the second excited state. It means that electron is present in the second stationary state. You have to calculate the energy for that one. This is your delta E. This is your delta E. It means that this is the change in energy when electron excites from ground state to the second excited state. Differentiate between the two statements. Try to use your brain, guys. That in the question they are saying that you have to calculate the excitation energy, energy of the excited state, not the excitation energy. Okay, if in the question they said that you have to calculate the excitation energy, in that case we have to use this formula. Okay, so all those who has started with this formula, so all the best to you guys. But unfortunately this is the formula, z square by n square. We have to just remember that we are talking about the second excited state. It means that n will be equals to what? 3. Okay, so if n equal to 3, this one will be 13.6, 3 square upon 3 square. Answer would be minus 13.6. Copy please. Is your change in energy. Clear? Guys, are you clear with the statement? The same confusion might develop in the examination as well. Guys, read the question very carefully in the examination, whether they are asking for the excitation energy or the energy of the excited state. Both are exactly different statements. Is it clear to everyone? Okay. Next question. Calculate the ratio of energies of helium for first and second excited state. Do this question. Who has got the answer? Anyone who has got the answer? Okay, so let's start. See, first excited state means N should be 2 and second excited state means N should be 3. Okay. Now, we know that we have to calculate the ratio of the energies of the excited state, means 1 to 2. So, this is your minus 13.6 Z square by N square. So, this is the helium. So, this is your 2 square upon 2 square minus 13.6 2 square upon second excited state means N equal to 3, which is 3 square. Okay. See, this will get cancelled out, this one will get cancelled out, and this one will be what? 9 by 4. Easy. Is this question clear to you guys? Itanagar, Tamelong, Sisipur. Okay, that's cool. Okay, so guys, one important thing that in the examination we have got MCQs over there. Okay, and remember, we should be very quick with the calculations. And one important thing, in the NEET examinations, don't expect that you will get very heavy calculations over there. Okay, so you have to be quick with the tricks. For example, in the last class, if you have remembered that I have driven ratios of the energies in the previous class, so you could directly use that formula as well. Did you remember that we have done something like that? Z1 square upon N1 square into N2 square upon Z2 square. This is direct formula that you can use over there. Okay. So guys, next question for you. Next, the energy needed to excite electron of a hydrogen atom from ground state to third excited state. Do this question. Tell me the answer. Guys, again read the question very carefully. And tell me the answer. Energy needed to excite the electron of a hydrogen atom from ground state to third excited state. What is the meaning of third excited state? What should be N? If you say third excited state, what should be N? Good. Do this question now. You can calculate the answer in electron volts. Is there anyone who has got the answer? Two more minutes. Can I start? If you have attempted this question, or you need some more time? Okay, let's begin, guys. See, in the question it is saying that the energy needed to excite the electron from ground to third excited state, it means that we have to calculate the delta E. 13.6 1 upon n1 square minus 1 upon n2 square into z square. Okay, because obviously whenever electron is changing its state, there will always be delta E. Okay, so we have to just put these values. Ground state means n should be 1, third excited state means it should be 4, so it is 4 square. They are talking about the hydrogen, that's why it is 1 square over there. So now on solving, 13.6 into, after solving this is 3 by 4, so you will get 10.2 electron volts. Is it clear to you? Is it clear to you, guys? Okay. Guys, can you please tell me that what problem exactly you are facing while solving the numericals? Because I have seen that in the Bose atomic model, I am not getting much responses. Can you please share your problem with me, that why are you not getting the answers? What's the problem? Or you are not solving? Sorry. Okay. Yeah, one thing. Then this one will be 15 by 16. That is 4 square. So in solving you will get the answer. Please solve this. Please solve this. Okay, using formulae. What's your problem, Shillong? And then Tamelong, Sisipo. Are you understanding the concepts? Is there any difficulty while understanding the concepts? Any problem that you find? Or is everything fine? What about you, CC4, Tamilong? Okay, this is the answer. 12.75 electron volts. Okay guys, so I am giving you the next question. See, I have told you that in the structure of atom there are lots of formulas over there. So guys, remember one thing, that you have to go through those formulas again and again, and then you have to practice based on those formulas. Okay? Until you won't practice, you will not be able to solve the question in the examinations. And trust me guys, questions are very simple based on this one. Very simple. You have to just make the understanding. Okay? If you find any problem while understanding the concepts, you can please let me know, so that I'll make sure that I'll explain each and every term clearly. Okay? So guys, next question. See, the ionization energy of hydrogen atom is 13.6 electron volt. The energy of ground level in doubly ionized lithium ion. I am giving you the options: minus 28.7 electron volt, number 2 54.4 electron volt, number 3 minus 122.4 electron volt, number 4 minus 13.6 electron volt. Attempt this question guys. See, I am discussing varieties of the questions. Okay. So it might possible that every time you feel that it is a kind of a new question. Okay. But after the discussion of the whole varieties, I am sure that you would be able to understand that how we can use those formulas. Okay. But again guys, you have to practice. Okay. Try to attempt this question. See, ionization energy of hydrogen is given to you. Okay. They are asking for the lithium ion. Okay. Ground state energy they are asking you. What can we do? Guys, try to keep in mind that formula, that E1 by E2 is equals to Z1 square upon N1 square into N2 square upon Z2 square. Please keep in mind that formula. Whenever in the question they talk about the different species, okay, it is possible that they might have the N1 same or Z1 same. We can say Z or N could be same, one of them could be same, other one should be variable. Okay, out of two energies, one will always be given to you, other will always be asked to you. Then in that scenario, you have to always use the ratio, means E1 upon E2. That formula you have to use. Please keep in mind that formula that I have just written for you. Did you remember that formula? That E1 upon E2 is equals to Z1 square upon N1 square into N2 square upon Z2 square. Whenever in the question they are talking about the different species, okay, energy of one of them is given to you, you can directly use that formula. Are you getting what I am trying to say? Good. Now use that formula and tell me the answer. Okay, we have got one answer. What? Is this the answer? I don't think so that this is the answer. This should be the answer. Itanagar, Tamelong, Sisipur. See, use E1 upon E2 is equals to Z1 square upon N1 square into N2 square upon Z2 square. Question is, ionization energy of hydrogen atom is given to you, okay. Energy of the ground level of the doubly ionized hydrogen atom. Doubly ionized lithium atom, sorry, okay. This is 13.6 given to you. E2 you have to calculate. For hydrogen atom, Z is 1. They are talking about the ground state, so obviously N should also be 1. N2 is infinity. That's why that one has got eliminated over there. Now, Z2 is the atomic number of the helium, which is 3 square. Okay, and obviously that they are talking about what? Ground state. Okay, so this N2 is actually what? Ground state of the lithium. So you can simply put it what? 1 square. Okay, simply by cross multiplying it, we will get our answer 13.6 into 9. Please tell me the answer. What could be answer for this one? This is simply trick, guys. In the option you can see that there are energies is given to you with negative signs. Okay, energy is given to you with the negative sign. This is a trick. Okay, so you can use the negative sign over there. You can use the negative sign over there. Any confusion in this? Else you can use the simple method, the normal method that we were discussing. Is there any option which is matching to this? Option 3. Okay, option. Okay, that was the answer given by you. Option 3. Who has got that answer? Option C. Okay, very good. You can put the negative sign over there. That is minus 122.4 electron volts. Guys, first of all, okay, only one student. Iba has got the answer. Only one student. What about others? Yes, that's the answer. But in the options, positive sign is not given over there. That's why we have to deal with the negative sign. Okay, because this was a simple trick. We have to solve the questions quickly. Okay, and you can simply relate that ionization energy is positive. Okay, very good. Ionization energy is always positive, but in the question they are asking for the ground level energy, which is always negative. See, guys, these questions, these kind of questions you have to practice again and again to be perfect in the examination. Okay. If it is clear to you, can I move on? If it is clear to you, can I move on? Okay. Next question. Second, separation energy of an electron in hydrogen atom. Options are 27.2 electron volt, option B 1.57 electron volt, option C 3.4 electron volt, option D is 13.6 electron volt. Do this question. I think so you have knowledge about the separation energy, so you can do this. Have you got the answer? Okay. Can we start? See, separation means sorry. Separation means energy to remove the electron from excited state to the infinity. They are talking about the second separation energy. It means they are talking about the second excited state. See, if they talk about the first separation energy, it means that they are separating the electron from first excited state to the infinity. If they are talking about the second separation energy, it means that they are removing the electron from second excited state to the infinity. It means that n should be 3. Okay, this is your n1 and n2 is obviously infinite. Okay, we can use this formula. Delta E would be equals to 13.6 1 by 9 minus 1 by infinity into 1 square. Okay, so we can simply solve this, and after solving this we will get our answer. Okay, so this should be your 13.6 upon 9, which is 1.57. Copy please. And who has got the correct answer? Shillong Center and other centers. Is there anyone who has got the right answer? Or any confusion in the question? Okay, very good. Okay, good. Guys, do we need a break? Who need a break? Oh, wow. Let's take a break of 5 minutes. See you in 5 minutes. Hi guys, back again. So, how was your break, guys? Was it refreshing? Can we start again? Okay, that's good. Is everybody has joined the class after the break? Is everybody in the class? Okay. Okay. Quite different. So guys, we were discussing about the, what are we discussing? We are doing some few questions, okay? We have done with the some questions, so let's begin with the next topic, hydrogen spectrum. Is everybody ready for the studies? Or do we need to talk something for the next 5 minutes? Or we can continue with the studies? Your choice. Tell me quickly. Okay. What about you guys? Other centers, Itanagar, Sisipur, majority will win. Okay. What do you say, Shillong? Okay. Okay, so as majority of you says talk, so let's talk about something. Okay. So I'll begin with you. Let's start that you can ask me few questions for the next 2 minutes. I'll answer your questions. Then it will be my turn for the next 2 minutes. Okay. Okay. So one is okay, so I'll start one by one. First one is that, sir, will there be holiday for the Christmas? Yes, there will be holiday for the Christmas. Relax. Okay. Second is your oh, this is a wow. Is this question CCPO? And next is give us little tips for the smart work rather than okay, Shillong, give me 1 minute, smart work. Smart work in studies. Focus on the previous year's questions, that the area from where maximum questions has been asked in the previous years. Okay, focus on those topics. Okay, that will help you out. Okay, while facing the examination. Okay, definitely you will do much better. Okay, if you have figured out that which section is covered maximum questions. Okay, so there's a pattern over there. We need to observe that pattern. I'll discuss about that. Okay, some other day. And okay. Actually, I would like to travel the whole world. This is what my dream is. Okay. And don't know from where I'll start. I think so. I have started with the India. Okay. And let's see. I'm working hard to achieve my dream. Okay. So that's all. That's first and last wish. That's what I would like to do. And other than that, yeah, I like to interact with people, with different people. That's quite interesting for me. Okay. See, we have interacted from the last month, 1 month. We haven't talked too much. So I'm sure that you don't know much about me, as well as even I don't know much about you. Okay. But yeah, definitely, whenever we meet, trust me guys, that would be one of the best days of our life. Okay, I'm sure about it. Okay, other than this, I'm not getting your question, Shillong. Can you please, what is this puja holiday? I'm not getting your question. Puja holiday means what, for Diwali? Okay, oh, I got your question, Shillong. Yeah, this is the only one, dear, where I can do a lot. I mean, many things included in this one. Them along to roam around the whole world. Over. Okay. Okay, so is there any gym freak in your batches? Anyone who is gym freak? I mean, who like to work out? Anyone? Okay. No, this is the only job, dear. I don't do anything other than this. This is the only one. Okay. Okay, so guys, anyone who is writer over there? Anyone who is writer? Okay. Shillong, am I audible to you? It's look very beautiful, Titanagar. Very beautiful. Okay. So, I think we have left with 25 minutes more. Okay. So, let's carry on with our studies. Okay. We will have some other conversation some other day as well. Okay. So, guys, let's begin with our studies again. Okay. And one thing is, please tell me first, is there any point of confusion or doubt till now that we have discussed in the structure of atom? Any doubt or confusion? Okay. So, guys, the next topic is hydrogen spectrum. See. This tube contains the hydrogen sample. Okay. Now, we are supplying energy to the hydrogen sample. Now, the radiations which got emitted by this hydrogen sample is being passed through a prism, and after passing through a prism, they will be obtained on a photographic plate. See, this is your photographic plate. On observing that, we have observed that there were 6 lines were observed. Sorry, 6 lines were obtained over there. Okay. Initially, we thought that there are 6 lines only, but after visualizing it with the help of ultra microscope, we came to know that every single line is made up of infinite lines. Okay. Initially, when we obtain this on the photographic plate, we are able to see only 6 lines. Okay. But when different scientists perform their experiments, they observe that there are not only 6 lines over there. Okay. Every single line was made up of infinite lines. Okay. So, different scientists have performed experiments on the basis of this one, and they gave their results that we have to discuss. Okay. First of all, guys, copy this one, and then we will discuss those results one by one. Basically, this pattern which is obtained on the photographic plate is known as what? Hydrogen spectrum. I think the spectrum word we have already dealt with that. What does the spectrum means? Copy, please. Done? See, first one here is your Lyman series, because the name of the scientist was Lyman, and the whole explanation about this one was given by the Lyman. That's why this one is termed as the Lyman series. It says that N1 should be 1 and N2 can have the following values: 2, 3, 4, 5, 6 and so on. Okay. this lies in the UV region, means these kind of radiations are available in the ultraviolet region. That's why this was ultimately given by the Lyman. Okay. Next is your Balmer series. Balmer says that N1 will be 1 and N2 will be, N1 will be 2, N2 will be 3, 4, 5, 6 and so on. Okay. Guys, first of all you have to just copy this one. Okay. Copy along with me. This lies in the visible region. Copy please. Done? Okay, let's move on. Next is Paschen series, where N1 will be 3, but N2 can be or 4, 5, 6 and so on. This lies in the infrared region, near infrared. Number 4, bracket series, where N1 is 4, N2 is 5, 6, 7 and so on. This also lies in the infrared region, in the mid of the infrared. Copy. Next, P fund series. Where N1 is 5, N2 can be 6, 7, 8 and so on. This is again in infrared region, but far. Okay. Last is your Humphrey series, where N1 is 6, N2 is 7, 8, 9 and so on, and again this one lies in the infrared region but very far. Now let's discuss what actually they are signifying. First of all, copy this. Copied. Copied, guys. Tamelong, Shillong, Sisipur, Itanagar. Have you copied that? Okay. Guys, look at the screen very carefully. Please do not copy anything. Okay, you have to just look at the screen. Guys, these are orbitals actually. Okay, n equal to 1, n equal to 2, n equal to 3. See, 1, 2, 3, 4, 5, 6. These are the orbits actually. Okay. Now, what Lyman has identified that in its series, that it doesn't matter that from where transition has started. Okay. Let's say suppose it is possible that it might start from 2 and ended up at 1. It might start with 3 and ended up at 1. It might start with 4 but finally end at 1. It might start from any point. But the point is it has to finish, or we can say it has to end up at n equal to 1. Whenever this situation comes over there, we will say it is a Lyman series. Okay, Lyman series means that it doesn't matter from where transition has started. The point is where it has end itself. Okay, where that transition is over. If that transition is over at n equal to 1, then you will say it is the part of the Lyman series. Okay, transition might start with at any point, but its ground state means its natural state will be fixed, which is n equal to 1. So this is your Lyman series. Okay. Now let's come to Balmer series. Same. It doesn't matter from where transition has started, but the point is it should ended up at n equal to 2. See, it might start with 4 and end up at 2. It might start with 5 and it might over at 2. It might start with at any point, let's say suppose infinite, but it should ended up at n equal to 2. So guys, this is known as Balmer series because this was observed by the Balmer. So on the basis of that name of that scientist, this series is known as the Balmer series. Now let's say suppose transition has started from n equal to 4 and it is over at n equal to 3. It starts with n equal to 5 and being over at n equal to 3. It might start with at any point, but the point is the final destination point is decided for that. So this is known as Paschen series. Okay. Now look at this. If n equal to 4 is fixed over there, then this one is known as the Lyman-Balmer-Paschen bracket series. Okay. Now again, doesn't matter transitions from where transition has started, but if its final point is fixed, which is n equal to 5, if this happens, then this one is known as the P-Fund series. Okay. If n equal to 6 is fixed, doesn't matter from where transition has started, this one is known as the Humphrey series. So guys, this is your actually hydrogen spectrum. We can draw this one in the spherical form as well, okay, in the form of hydrogen atom. But to visualize this clearly, I have chosen this one. So I hope so it is clear to everyone that Lyman means N1 will be fixed, Bomber means N1 will be fixed. Past tense means N1 will be fixed. Means in every series your ground state is always fixed. Okay. But N2 is not fixed over there. Okay. For the Lyman, N1 is 1. For the Lyman, N1 is 1. For the Bomber, N1 is 2. For the Passion, N1 is 3. For the Bracket, N1 is 4. For the P-Fund, N1 is 5. And for the Humphrey, N1 is 6. Okay. That's what this series means. Okay. Please copy this. Copy this. What's happening, guys? Shillong Center. Second and the third bench. Guys, please copy this. Done? Shillong, have you copied that? Shillong, Tamelong, Sisipur. Okay. Okay. Any confusion or doubt? Anybody wants to ask me anything regarding this one? Anyone wants to ask me anything? Or is it clear to everyone? Is it clear to everyone? Okay. Guys, please attempt this question. Calculate wavelength of first line of Bomber series in hydrogen atom. Okay. First of all, guys, remember that you have to use this formula. Okay. RH 1 by N1 square minus 1 by N2 square into Z square. First of all, tell me what will be the value of N1 and N2. Guys, first of all, just confirm me that what should be the value of N1 and N2 for this question. What should be value of N1 and N2 for this question? Okay. What about N2? See, guys, first of all, clear this one. Clear this one. Look at this first. This is your 1, 2, 3, 4, 5. Okay. we are talking about the Balmer series. So Balmer series means that N1 should be 2. N1 should be 2 for the Balmer series. Okay, they are talking about the first line. First line means that exact the next number of the ground state. Okay, so guys, obviously when transition takes place from 3 to 2, it should be what? Its first line. If transition takes place from 4 to 2, it will be its second line. See, this is your first line, this is your second line. If transition takes place from this to this one your third line. Okay, if transition takes place from 10 to 2, then it means it will be its ninth line. Okay, is it clear to everyone? Is it clear to everyone that N2 should be for first line, for the first line, when we will observe, when we will obtain the first line. Okay, we will obtain the first line when N1 should be 3. This is the first line. So guys, you can put the values and solve this question. Please solve this question, tell me the answer. Put the values and solve this question. Put this one as 2 and this one as 3. How many students are there at the Itanagar center? Anyone there who has got the answer? Anyone who has got the answer? Okay. Guys, solve this question and tell me the answer. Done? One 10 to the power 7, 1 by 4 minus 1 by 9. On solving this one, 1.1 in 10 to the power 7. So this is your 36 5. Okay, 1 by lambda. So lambda would be equals to 36 upon 5.5 into 10 to the power minus 7. On solving this, we will get 6566 angstrom. Copy this. This is the answer. Okay guys, so that's it for today's session. Okay, please revise till the topic that we have discussed today. We'll practice few more questions on based on these topics. Okay, see you next time. Till then, take care. Bye bye. Have a great time. See you next time.